Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is statics tutorial. We will be dealing with vectors in 3D space, 3D problems. This is continuation from the previous tutorial, where in the previous tutorial we have already give you we already solved question from the past exam question in vector for 2D, right? For this case, for this tutorial, we'll continue on with 3D problems, inshallah. So all the questions are from the previous exam questions, past exam questions. The PDF of the question that we will be solving today is in the description box below. You can download the PDF, see which question you want to, cover, and inshallah in the timeline, if you go your mouse on the time, we will segregate it into the different questions. So you can straightway go to the question that you are interested in, where you know exactly when it started based on the timeline, inshallah, right? So yeah, without further ado, I think also do refer to the comment section below, or write in the comment section below if there's any mistake that is observed in any of this tutorial, inshallah. With that, we'll go to the first question. So this is the question. As you can see the diagram, you have a structure where there's a cable and then there's a force of 400 Newton pointing downwards as shown there, right, at an angle. So the question asks to express the force 400 Newton as a Cartesian vector. Now, these questions are from the past exam question, but actually the question is much longer. The rest of the question is not from this topic. It is from the later part of chapter 2 or other chapter 3 or chapter 4, right? So but one small part of the question is to express the 400 Newton as a Cartesian vector form. So we are dealing in this tutorial, we are focusing on how to express each force in 3D as a Cartesian vector form, as well as finding the addition or resultant force, right? So that is our focus today. So we will see any question from the past exam that deal with that, and this is one question of it, right? So do not expect the question just to ask a small question like this. It's actually a longer question, but it begins with what we are learning today, right? So hopefully you have no problem whatsoever with expressing force in 3D as a Cartesian vector form from now onwards, inshallah, right? So looking at the question. Simply how to express that as a Cartesian vector form. So this is so simple actually. However, if you struggle with it, make sure never delay about resolving it. Make sure you understand it here and now, right? How to express this as a Cartesian vector form, right? So basically what we do is we have to identify the x component, y component, and z component, right? And then we express it straight away. So f is basically just x component I plus y component j plus z component k. Okay, there's some glaring there, so I'll bring it down a bit. So let's say here, right? F. Right, so you have to be able to identify just by looking, right? If you look at that force, what is the x component of the force? What is the x component? It should be 0, right? 0 I. If you have a problem to identify this, make sure you try to see how to understand a 3D diagram, right? It should be simple, because if you can see the 400 Newton, it makes a triangle of 30 degrees there, meaning that it is on the YZ plane, right? If you are on the YZ plane, it doesn't have any x component, right? For example, if you have x-axis, y-axis, z-axis, right? X, y, z. So the force is actually between y and z, right? The 30 degrees is here, so it doesn't have any x component, right? Hopefully you can visualize that. So 0 I. And then y component. Y component is positive, and it is basically, so you have plus, okay, all my markers are plus 400 sine 30 degrees j, right? So it's basically just to see the triangle, right? So if you cannot visualize, make sure you can, this, by the time we reach the end of chapter 2, you should be able to visualize already. Otherwise, if it's a problem to visualize, no problem, step by step, you just look at the triangle that makes the 30 degrees. Imagine you are looking perpendicular to the triangle, and you will see that the triangle is like this, right? You're looking straight at it, right? Of course, from the diagram, it's at an angle, right? But you just imagine yourself seeing straight at it. So this is the 30 degrees, and then this is 400 Newton, right? And X component is going out here, but it doesn't have any X component. Y component is which one? This one, right? Z component is this one, if you can imagine. So, of course, this Z component is downwards, right? So, the Y component is this, meaning what? 400 sine 30, this one, right? 400 sine 30. And then what is the Z component? Here, it is negative 400 cos 30 degrees, K. Right? So, that is it, right? Now, if you have, I assume if you are my student, I assume all of you have already covered the crash course for trigonometry, right? Because I explained there what you need to understand about trigonometry so that you can learn the statics, right? Because all of these you should already understand before you learn statics. But that video is specifically for you if you need to refresh that, how to imagine this, how do you get this, etc. Alright? So make sure you have covered that already. If you haven't, go back, cover that first, and then cover this back. So from here, you just solve, and basically, so the answer would be straight away what? So it's 0i plus 200j minus 346.4k, is it? Newton. Right, so basically, if you express the force in Cartesian vector form, is just simply this one. Right, this is this is not even a question actually. Right, it's actually a small part of a longer question. Right, so this is the first step. You have to be able to express the force in Cartesian vector form before doing the following calculation. Right, so but for now we stop here because we are focusing on this part. Hopefully you have no problem here, and yep, that's the answer for this part. Let's move on to the second question, and that is the second question. We have to express F as a Cartesian vector form. So F is 180 Newton, right, at the angle shown. So this is where some students actually find it difficult to even get the Cartesian vector form or even imagine what's going on there. Make sure, again, I'm reiterating here, make sure you have covered already the video that I do or specifying on the crash course on trigonometry, right? That is important for you to fully understand that, so that we can go with this, inshallah, with no problem. Right, so how to express that? Now, for those who already can visualize what is happening, you can straight away come to the expression straight away, right? For example, F, just looking at it, you can see what is the X component. Okay, so it is 180 cos 30 sine 40 I, right? 30 40, right? Sine, cos, sine, and then it's positive. So Y is also positive, plus 180 cos 30 cos 40 J, and then Z component is downward, so minus 180 sine 30 degrees K. Right? So if you already can visualize the two steps, it will become like this straight away. Right? Hopefully my marker is still okay. Is it clear? You can still see, right? Hopefully. Okay. But of course, as I mentioned in the trigonometry video, if you still need to do step by step the two triangles, please do so, right? So if you do that, let's use another color. So if you look at the 30 degrees angle triangle, if you look perpendicular to it, so it will be something like this. This is the 30 degrees, right? And then this is 180 Newton, right? So here is a simple trigonometry where you can say this is 180 cos 30 degrees and this is 180 sine 30 degrees, right? And if you go to the other triangle where it is 40 degrees, if you look from top, it will look straight away like this, right? 40 degrees, right, from the top, right? So we know this line here is the same as this line here, right? You understand? Sometimes we use f prime or whatever, but you know that this line is exactly this line if you look back at the diagram there, right? So meaning that we already know this is 180 cos 30 degrees, right? From here, this is the same line as this, right? So it should be the same value. So what to do? So for this one is the whole thing cos 40, right? So if you have 180 cos 30 degrees and then cos 40 degrees, and then this one is 180 cos 30 degrees, meaning this is the whole thing here, and then sine 40 degrees, right? And you should be able to see that x component is this one, yeah, from top here, this one. So you get 180 cos 30 cos sine 40, right? 180 cos 30 sine 40, and y component is this one, so 180 cos 30 cos 40, it's the same, and z component downwards is this one, so minus 180 sine 30 degrees. And then you get your of course, just solving this, you get your values. That will be the force of 180 in Cartesian vector form, right? So anyone who still struggle to do these two steps, make sure you try until you understand. It is crucial. Never wait until next tutorial, never wait until next class, because this will come again and again, this kind of angle, right? That kind of angle. So it should be just less than 1 minute, we know how to get this, because it's just chapter 2, we just learned about the first step of 10-12 steps calculation, right? So if you struggle with the first step, the whole semester will be quite a nightmare, right? We want to avoid that. Please understand this fully. If you need, ask question, discuss, etc. Do whatever it takes to understand this today. All right. Third question. This is the third question, and we have two forces. One is F1 400 Newton, another one is F2 500 Newton. The angle is given, so this is where the first question that we found, where we have alpha, beta, and gamma, right? Coordinate direction angle, right? So of course the F1 is still projected angle, just like question number 2. Hopefully you already resolved that, how to get this one, right? Right, so how the question says express F1 and F2 as Cartesian vector. So that's part 1, expressing F1 and F2 as Cartesian vector, and then we need to calculate the resultant, right? All right, so F1 in as Cartesian vector form. Okay, I might need to make sure the way you write vector and scalar is clear. Do not lose mark there. You have to have the arrow, etc. for vector. Make sure that is clear, right? So now F1 400 newtons. Okay, so we have the two triangles. So if you can straight away see, then you'll get F1. What is the x component? So 400 sine 60 degrees, cos 20 degrees, I sine cos, all right, positive, right? Y component is negative, right? It's the other way, so negative 400 sine 60 degrees and then sine 20 degrees, J. And then Z component, so plus 400 cos 60 degrees, K, right? And then you can just calculate, right? I think the calculation you can do just straightforward. Okay, maybe we'll just put this So it will be 325.52i, and then minus 118.48k, and then plus 200k. Okay, so that is for F1. Of course, you can do step by step. If you still need to do step by step, please do step by step so that you do not make any mistake. Do not guess this. This one should be correct based on understanding. Do not, I think sine, I think cosine. No, make sure you understand what's going on. So the easiest way is to do step by step using the two triangle. Of course, this one is actually doing with the two triangle as well, but the two triangle is already, you can imagine in your head, right? So sine, cosine, whatever, right? Of course, if you use the two triangle, this 60 degrees will be 30 degrees on the opposite side, because the triangle, because if you know, okay, if I redraw the triangle here, right, this 60 degrees is here, right? So this means this is 30 degrees. So if you use this triangle, you might use this 30 degrees, so this become cosine 30, cosine 30 and sine 30, right? It will be the other one. Okay, but the answer, this is the value, will be the same. So I let it for you to do the two triangle, and it should be having the same answer, right? What about F2? F2, you have alpha, beta, gamma here, so that is straightforward, should be. So just magnitude 500 and then cos alpha. Cos alpha is 60 degrees I, and then plus 500 cos beta. Cos beta is 60 degrees J. Enough space? Okay, we'll put here plus 500 cos 135k, right? So we'll just plug in cos alpha, cos beta, and cos gamma. If you calculate this one, automatically you get the positive or negative. So you get 250i and then plus 250j minus 353.55k, right? So both of these are in Newton. So this is Cartesian vector form. So the question, again, two parts. One is F1 and F2 in Cartesian vector form. We have completed already. Next is what is the resultant, right? So after you have obtained this, the resultant is simply Fr is just F1 plus F2, and you just add the component, right? X component, Y component, Z component. So 325.52 plus 250 becomes 575, right? 575.5 I, and then so negative 118.48 plus 250 becomes 131.5 plus 131.5 J, and then 200 minus 353, so become minus 153.6 K Newton. This is your resultant, right? So yeah, the question can give either projected direction angle, like for this one, or coordinate direction angle like this one, or something that we will cover next, which is using coordinates and position vector, right? We haven't covered that yet. So make sure, because the question can mix up like this, right? So this force is in this type of angle, this force is in this type of angle. You have to know each. If you know only how to solve this one but not this one, you cannot get this one, right? So make sure everything is understood and you are able to solve it on paper without any problem, without any mistakes, right? So that's the two component that is critical for you to excel in the exam. Not only you need to be able to get the correct answer, but actually be able to get the correct answer in the given time. If you are taking too much time, sometimes you know how to solve, but you do not have enough time in the exam. You still will lose a lot of mark because of that. So make sure you have enough practice and you can solve this in the minimum time required. Right, so that is it for this portion. Next we will go into the position vector using the coordinate, etc. To find the same thing but with different method because the different information that we have, right? So with that, I think we'll end the session. Hopefully you have understood, and again I have to reiterate this many times because I hope you really understand this. I'm stressing this too much because anything that you do delay from understanding from this part, it will haunt you later. So do not delay. Make sure you understand fully. With that, subhanakallahumma wa bihamdik, ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.